Alright, hello, we're the Chain Lube Lieutenants, and here is our motor. This motor is made out of many layers of laser cut acrylic, and it has some magnets on the side and is held together with some threaded rods, and then we have the axle in the middle, and then as you can see, we've got the windings and the commutator system on the inside, and we'll dive into that. For some explaining for why we chose this design, we wanted to have something that would allow us to be a design that's easily, that could be easily like assembled and reassembled, and also something that would show us what the motor looked like while it was spinning at the same time, while also being protected on all sides from external factors. For a little bit more specifications on the parts that we laser cut, we added in some grooves right here for the first magnet, and then put on a protective outer layer so the second magnet could be attached but also not stuck together. We added in some supports right here for the base to make sure that it doesn't wobble too much as the motor spins. And finally, we added in some extra grooves right here to secure the bearings that the axle would go through. And for some more specifics, I'm going to hand this off to Juan to explain some more.
Alright, so I'm going to talk about the commutator system. Our commutator, I don't know if you can see through that, but it's made out of a 3D printed piece with 6 copper pads glued to it, and then the wires and the coils are soldered to those pads. Frankly, the commutator system works fine as is, but it was a bit of a mistake we found out later on because we made the diameter too small and the pads too small, which forced us to have the brushes sliding over the area where the wires are soldered. This meant that the commutator surface is not smooth, it's full of bumps. I don't know if you can hear it when it spins.
I can hear it.
This provides a bit of an unreliable connection between the brushes and the pads, and it also increases the amount of friction between them, which means that the motor spins less freely, which is a very large component of why we couldn't achieve any kind of decent RPMs.
Alright, and lastly, we opted to use brushes instead of brushless for our motors. So we have two copper, it's kind of hard to see through the acrylic, but we have two copper sheets bolted in such a way that they're constantly pushed up against the commutator and making contact. And yeah, the one downside to that is it's adding a little bit of friction in the system, so we're losing some energy to heat. And our pads are copper plated, so over time they could wear possibly, but it was best for our design.
Oh, wow.
And yeah,
And here's the inside, our rotor, everything together. We got the windings, the pads all soldered up, and yeah, thank you.